geobyte.
Similarly, let us take the another important problem. Look at this problem. It is asking like this. The bob of a pendulum was released from a horizontal position. The length of the pendulum is 10 meter. If it is dissipating 10% of its initial energy against air resistance, the speed with which the bob arrives at the lowest point is. It is like this. Look at the simple pendulum, but it is given that the pendulum is initially horizontal. The length of the pendulum L equal to 10 meters it is given. Okay. If it is dissipating 10% of its energy against air resistance, the speed with which the bob arrives at the lowest point. That means by the time the bob is moving from horizontal position to vertical position, horizontal position to vertical position, vertical position, it is like this. Horizontal position to vertical position, right? A minute. By the time the bob is arriving from horizontal position to vertical position, given that 10% of energy loss is happening because of the air resistance. Look at the G value given. G value given 10 meter per second square. By the time the bob reaches to bottommost point, what will be the velocity of the bob? Let this is the position of the bob A, where velocity is 0. This is the point B, where the velocity is VB. That VB you are asked to decide. This length equal to height with respect to original point, that is given as 10 meters. This one, right? This one. Okay. Now, with respect to B, with respect to B, the height equal to 0. That means there is no potential energy in the bob by the time it reaches to bottommost point. Okay. For deciding the for deciding the velocity of the bob after it is reached to bottommost point, let us connect the work energy theorem. According to according to work energy theorem, the total energy at A must be equal to total energy at B. Here total energy means mechanical energy only. I can also write that mechanical energy at A equal to mechanical energy at B. Here total energy means potential energy plus kinetic energy at A is equal to potential energy plus kinetic energy at B. Means UA plus kinetic energy at A is equal to UB plus kinetic energy at B. But already we have decided that the velocity at A0 means kinetic energy at A0. Kinetic energy at A0. The elevation at B0 means potential energy at B equal to 0. So finally, the conclusion is the potential energy at A equal to kinetic energy at B. Potential energy at A equal to M into G into H equal to half into M into velocity at B is VB square. This M is cancelling. Finally, it is GH is equal to VB square by 2. But the thing is, here 100% of the energy is not converted to 100% of potential energy is not converted to kinetic energy, because it is clearly given that 10% of initial energy against air resistance, right, uh, is lost. That means it is like this. Take a minute. It is like this. So only 90% of energy is available for converting to other form of energy. This is zero point 0.9 times. Zero point 0.9 times. Zero point 0.9 times. You should be very careful. So zero point 0.9 times. So zero point 0.9 into G, 10 into H is nothing but L only 10 equal to VB square by 2. Therefore, VB square equal to 2 into zero point 0.9 into 10 into 10, 100. It is, you know, 180. It is 180. VB square equal to. Then VB equal to root over 180. That 180 I can write as 36 into 5. 36 multiplied by 5 is giving 180. 36 can be written as 6 square. Therefore, VB equal to 6 root 5. That is the velocity of the bob by the time it reaches to bottommost point. 6 root 5. 6 root 5. Option A is absolutely correct. Understood clearly? Yes. Similarly, let us take the another problem. Try to read it clearly. It is asking like this. A bob of mass m is suspended by a light string of length L. A light string of length L. Look at that length given, length of the bob with respect to origin O. It is imparted a minimum horizontal velocity at the lowest point A. The minimum velocity at the lowest point is VL given. Okay. A, such that it just completes half circle reaching the topmost point of the V. Velocity at B is given as VH. Similarly, velocity right after completing 1/4 of the circle is given as VM. VM. The ratio of kinetic energies at A, kinetic energies at A and at B, how much? You know, the velocity in the circular path at bottommost point is put under 5GL. The uppermost point is root GL. At the midpoint of the semicircle is root 3GL. Okay, you try to remember those values. Then kinetic energy at A dividing by kinetic energy at A dividing by kinetic energy at B is equal to half m ma va square divided by half mb vb square. So the same bob is moving from bottom to top. Mb equal to ma, half cancelling. Finally, it is equal to va square by vb square. vb square. Here we have decided va means here vl only. Va equal to VL is equal to root 5GL. VA square equal to VL square equal to 5GL, and VH square is nothing, VH is nothing but VB only is equal to GL. GL. 5GL by it is equal to 5GL by GL. GL. Finally, it is equal to 5 by 1. Therefore, kinetic energy at A dividing by the kinetic energy at B is equal to 5 by 1. That is the answer. Okay, look at the options. 5 is to 1, right? Option B is correct. It is like this. Kinetic energy at A east Kinetic energy at B can be written as 5 is to 1. Okay, na? Understood clearly? Yes. Then it is also very important problem, most expected problem. Right? Similarly, let us take the another important question. Try to read it clearly. It is asking like this. A block of mass 100 kg slides over a distance of 10 meters on a horizontal surface. If the coefficient of friction between the surface is zero point 0.4, then work done against friction. It is like this. There is a horizontal surface. There is a horizontal surface. Over that horizontal surface, there is a block. There is a block. Right? That block of mass is given 100 kg. Now, through the center of gravity, the self weight is acting vertically downwards. Then normal to the contact surface. This is the contact surface. Contact surface is horizontal. Therefore, this is the normal reaction. Normal reaction is perpendicular to this is the normal reaction. Right? Of course, that n equal to mg only. Now I am going to apply some external force. I am applying some external force on the block. Then that block is moving to a distance s is given 10 meters. 10 meters. Coefficient of friction is given zero point 0.4, zero point 0.4. Since the block is moving, this is the direction of motion. Then frictional force acting opposite direction of motion. The frictional force Ff equal to mu n, that is equal to mu into n equal to mg. Is asking work done against the friction. Against the friction. Work done against the friction means the frictional force multiplied by the displacement. Frictional force mu mg. Let me simplify it. Mu value 0.4, m value 100 into g 10. It is 40 into 10 equal to 400. 400. 400 multiplied by the displacement is 10. 10 is equal to 4000 Newton meter or joule. The force is in newtons. The work done is in Newton meter or joule. 4000 is the answer. Look at the option C. Option C is absolutely correct. Are you following? Yes. Similarly, let us take the another important problem. Try to read it clearly. It is asking like this. The potential energy of a particle in a region of space is given U equal to potential energy is the function of the displacement 2x square plus 3y cube plus 2z. Here x, y, z are in meters. Okay. The magnitude of x component of force acting on the particle at a point. The point P is given 1, comma 2, comma 3. 1, comma 2, comma 3. The point P is given 1, comma 2, comma 3. This is the x value. This is the y value. This is the z value. Right. Now force equal to you're asked to decide the magnitude of x component of force. X component of force equal to du by dx. Just it is 4x. Simplify it. 4x. But x equal to how much? 1. Therefore, the x component of force is 4 into 1 equal to 4 newtons. That is the answer. Very simple question. Right? Very simple question. It is asked for JEE mains in 2024. Right? January shift 1 29th. Okay. Similarly, look at the another important question. Try to read it clearly. Asking like this. Two bodies of masses 4 grams and 25 grams are moving with equal kinetic energies. That means kinetic energy of the body 1 is equal to kinetic energy of the body 2. Mass of the body 1 is given 4 grams. Mass of the body 2 is given 25 grams. The ratio of magnitude of their linear momentum. That means linear momentum of the first one dividing by linear momentum of the second one, how much? Or P1 is to P2 is how much? Okay. For that, as you know, the kinetic energy K equal to, as you know, half mv square. It is equal to half mv whole square dividing by m. So kinetic energy equal to the product of mass and linear velocity is the linear momentum p square by 2m. P square by 2m. So here, since kinetic energies are identical, I can write P1 square by 2m 2m1 is equal to P2 square by 2m2. This 2 is cancelling. 2 is cancelling. Then it is P1 square by P2 square equal to P2 square equal to P1 square by P2 square equal to M1 by M2. M1 is 4 by 25. Then P1 by P2 equal to root over 4 by 25. It is equal to 2 by 5. 2 by 5. Therefore, the P1 is to P2 is equal to 2 is to 5. 2 is to 5. Look at the option C. Option C is absolutely correct.
Geobyte.